Hello, this is Ruth Guthrie presenting a module on systems development. Specifically, the systems development lifecycle, the process you go through to develop software or systems. It's also known as the project development lifecycle or the software development lifecycle. The process is pretty much what you'd expect: problem definition and planning, requirements analysis, design, code, test, and maintain. It's breaking the problem into logical steps so that you can be successful at the completion of the project. So the first phase, the problem definition and planning phase, is when we'll see if the system actually has viability. Will it improve efficiency or effectiveness? We'll define project goals and we'll develop a high-level plan to meet the goals of the project. In requirements analysis, we'll define in detail the functions and operations of the system. During the design phase, we'll develop the structure for how the system will work. This will include user interface design, the front end, database design, the back end, interface descriptions, etc., etc. It's everything describing how the system will work and how all the components will work together. During the development phase, we code the system that we did the analysis and requirements for in the past. We also do some testing to make sure our code is working properly. Then we go into formal test. The formal test phase is where we test to the requirements. We've got requirements that were at the beginning of the program. We have requirements from the beginning of the project, and we'll do subsystem testing, integration testing, and load testing, usability testing, and make sure everything works as we said it would. Then we implement the system, which means it'll go live where people can actually use it. And then after the system is successfully delivered, there'll be a maintenance cycle where problems or upgrades to the system will be done. Most of the money in a traditional project is made during maintenance contracts added on after the project's done. The waterfall model was the first robust development methodology that occurred in software engineering. So the strengths of that model were it was very simple to understand and had very well-defined product milestones. At the end of requirements analysis, you had a review, and you knew that was the closure of that part of the process. At the end of programming, you had a review. People would sit and look at lines of codes and review the code, and you knew that you'd met that milestone, and it would go through the entire project, and then at the end you were done. It was really great for well understood, well-defined projects with short time horizons. It was also protection against fickle customers in that specifications are concrete baselines that you had to perform to. So if you got to the end of the coding phase and the customer said, hey, I want this and this and this instead, which customers often do, you could go back to the beginning and say, wait a minute, these are the requirements that you signed off on and agreed to, and that's not part of it. If you want us to change something, it's going to cost you more money. With waterfall model, there's great requirements traceability. That means you can go back and say, this is requirements 2.1936, and you can go through the life cycle and see where that requirement was met and where you tested it and where you met your deliverables. But it wasn't all great. The waterfall model got a lot of bad press because it didn't meet the customers' needs. They found it inflexible and that the lengthy time between requirements and the working model resulted in users being upset and users saying, wait, this doesn't meet our requirements. That's not what I wanted. And there was a real failure to leverage current technologies, meaning that at the start of your program, certain technology was available. And by the end of the program, the technology had advanced enough that something else would have been more appropriate. For long projects, this was particularly true. So it's plagued by low satisfaction and high cost. Incremental development means you break down the project into smaller sets of life cycles so that your customer is going to be happier. So if their life cycles are a little shorter, you have a better chance of meeting the client's needs. So you see there's 3 different sets here. Think of that as a separate waterfall life cycle for each one. A classic way that they install SAP is to go to an organization and say, okay, we're going to do payroll first, then we're going to do accounting, then we're going to do human resources, then we're going to do employee records. The project will be divided into several different increments so that you're successful with one and then you move on to another. You're successful with the second one, you move on to the third. So you integrate after implementation of each major subsystem. The strengths of incremental development are that it does give you some flexibility on requirements. You've got functionality and success along the way, and you don't have to wait 5 years till the whole thing's implemented. It also breaks large system problems into achievable pieces. You can tackle one, tackle the next after that. And if you run out of money or if something becomes obsolete, then at least you've got the functionality of what you've already implemented. The weaknesses are that it requires really well-defined interfaces, and SAP certainly has that. It's also costly because instead of doing one giant project, you're doing maybe 6 or 7 iterations. So there's many integration cycles, and that's added cost to the final cost of the project. There's also a tendency to delay difficult problems. So if I'm doing incremental design, I might pick the easiest part and do that first because I want to get things underway, and then do my harder problems later, much like doing your homework. Same thing, you might do the easy homework first and then work on the harder things the day before it's due. Prototyping. The big problem people want to solve in software development is getting user requirements, and prototyping is a fantastic way to find out what your users really want. So with prototyping, you have a working mock-up of the system. This means you might have drawn pages or a fake website where a person can click through and exercise the software when it's not really a working system. It doesn't have a back end and it doesn't integrate with other systems, and the person can sit down and try it and tell you exactly whether it meets their needs or not, what's missing, and how they feel about it. From that, you generate your customer requirements. And having someone sit down at a system is a lot more effective than having them read a requirement and say, yes, I guess I need to log on. Strengths of prototyping are early functionality, that is, early functionality of the user interface. It also gives you good risk control because your clients are going to know exactly what you're producing and have buy-in early on in your project. It solves the problem of identifying customer requirements by providing operational mock-ups that they can actually try. Prototyping traditionally has high customer satisfaction, and the development is highly focused on the end product, a good thing. Weaknesses of prototyping include use of the prototype as the system. Sometimes when something's built or halfway built, people will decide to put it into production, and often it's got serious problems with the logic or the functionality behind the user interface. Often customers don't understand that the prototype is the front end. It's not really a working system. And when you say, okay, thanks for the requirements, now we're going to go back and it's going to be 6 months before you can use it, they're a little disappointed, and they'll say things like, why can't we just use that? Because they don't understand it's not a fully developed system yet. Sometimes, since so much of the focus is on the user interface, the system you end up with has poor performance and documentation. Prototyping also has a tendency to delay difficult problems. You don't know what the showstoppers are until you're at the end of your development. And of course, prototyping really doesn't apply to maintenance projects. So we had incremental design and we had prototyping, and we still have trouble having successful projects and meeting users' needs. The next methodology to be developed was called Evolutionary Spiral Model. And with the Evolutionary Spiral Model, the focus was on minimizing risk. So you'd see one spiral or several spirals that went through 4 different phases. 1, determine objectives, alternatives, and constraints. 2, evaluate those alternatives and identify and resolve risks. 3, develop and verify next level product. And 4, plan the next phases. So our life cycle is all in the quadrant with the 3. That's where we're running our life cycle, except we do it for a smaller piece of the project, and then we do all our requirements, coding, and test right in that quadrant. But a lot of our time was spent on planning and on risk reduction. This is a picture of the evolutionary spiral model that's a little more fleshed out, and it shows 5 phases: understand context, analyze risks, plan and development, develop product, manage and plan, and then little subtasks associated with that. But again, I'd like to emphasize, it's not just one spiral you're going through. This would be one spiral at the beginning. You'd think of more requirements and decide where your project was going in understanding context, and you'd develop more spirals to go on to that. So you'd have 100 spirals meeting together to develop your project. It's broke it down, but every single spiral would go through this process. Does it sound complex? It is. Pros. The pros with spiral development is it's flexible, so you have a better chance of meeting your users' needs. Risk is well managed because you've spent so much time. You've really paid attention to risk, and so problems that are going to occur, you're aware of them and you can mitigate them before they happen. It's good for a really complex project. Cost. Also, you're more accurate at determining what your project will cost because you've broken it down and you're determining the cost as the project goes along. Cons. The spiral model can be expensive and complicated. It already looks complicated with those big spirals, and how are they all going to feed together? It's too complex for a simple project. If you're going to do something simple, why would you overload yourself with this complex methodology? Too much documentation. People didn't like that there was so much documentation and you have to do one at the end of every spiral, and it's a lot of work. And this kind of methodology calls for a really experienced, smart project manager that can manage all the complexity of integrating the spirals together. So our last methodology is what's called an Agile methodology. Agile development is a school of development where the focus is really on end users and functionality and tries to get away from a lot of documentation and focus on technology. The methodology we're going to go over is Agile Scrum. You can see that it comes out of spiral model because it has spirals, but now they're called sprints. But that de-emphasizes the documentation and focuses on functionality. So in this figure, we see that there's a product backlog. The product backlog, represented by those little cubes, each cube is functionality that the customer needs. So you go through requirements definition and you determine everything that the customer is going to need in a product, and you divide it out into all these different features. And then we have what's called a sprint backlog. In the sprint backlog, you take your features and you say, these are related, they're going to be part of sprint 1. These features are related and they're going to be part of sprint 2. These will be part of sprint 3. And then you develop each sprint. You don't have a formal requirement specification, but the features, your little cubes, are representing the requirements. So you don't spend a lot of time on documentation, and you take all the features that you put into sprint 1 and you rapidly develop it in a period of 3 to 4 weeks. Then you go back and you do sprint 2. But each sprint will have functionality that the user can see and test and give you feedback on as the project evolves. So there's functionality delivered to the user at the end of every sprint. And you need to prioritize your sprints so the most important features to the user are done first. So if you've got a lot of features and some really help the user get their job done and some are nice to have or okay to have, you put those at the end of the life cycle so that if you get cut off in the middle, at least the user has the functionality that you developed first up front. So with a Scrum team, you've got a Scrum Master, a Scrum team, and a product owner. Yes, there's actually a position called Scrum Master, and if you go onto DICE or Monster and search for the job title Scrum Master, you will see that there are actually people out there in industry with that name. Develop requirements, sometimes called user stories, but they're not full-blown requirement spec. It's little sticky papers with the requirements written down and estimates for how long they'll take. Prioritize and divide the requirements into sprints with the functionality that the user requires most up front, deliver a few sprints every 2 to 3 weeks and change the requirements as you go, and do sprint reviews with the user at the end of every sprint. Scrum pros and cons. The pros are early functionality. It makes your customer happy. They can see what the functionality is early on and they feel like the progress is progressing and it's a one-to-one match with their needs. Scrum also has small development teams, usually 5 to 7 people, and it's a lot easier for 5 to 7 people to communicate the project goals than it is for, say, a team of 50 developers. Much easier communication. Also, requirements flexibility allows the project to change. After every sprint review, requirements may be changing, and so you're much more likely to meet your customer's needs as the project evolves. Cons. It's hard to manage something that isn't well defined. Imagine you don't have all your requirements set in stone at the beginning, and things may change a lot. Keep the project on time and in budget as these things change. Also, a lot of time is spent doing reviews, sprint reviews, because you do a review after every 3 or 4 weeks, and you've got to prepare for the review and get everyone together to meet with the user and get their feedback. So while it really is good at communicating with the user, all that time spent in reviewing is time that you're not spent developing. The third con is that requirements change a lot. If there's a lot of change, you're going to spend a lot of time in redesign. This also isn't making the project move forward, it's redesigning what you've already done. So in some sense, that's wasted time. And the last con is that it may be difficult for a complex project to be done under Scrum. In summary, the 5 different methodologies we've gone over: Waterfall, top-down from beginning to end; Incremental development, that means you've got several small waterfalls that you integrate after the completion of each one; Prototyping, where you have a working mock-up of the system that the user can give you feedback on; Spiral development, where you break project requirements into several different spirals to work towards development and manage risk; and then Agile Scrum, where you've got sprints instead of spirals. You de-emphasize documentation and you emphasize group communication and getting early functionality done when you deliver the project. Quiz time. If your project is really well understood and highly structured, what methodology might work for you? Waterfall. If you're expecting requirements to change and evolve as the project grows, what type of methodology might work for this? Scrum or prototyping? What happens if you blow it on the requirements at the beginning of the project? What happens later on? It costs you more money to fix it towards the end of the project lifecycle.